the absolute configuration of. So you have to give the notations the rectus or sinister. Rectus means the clockwise and the counterclockwise is sinister. Now this is given in case where there are the chiral carbon atoms, right? Now see, if I take up the first carbon atom, this is thing, right? In this first carbon atom I have got the 4 groups, all different. This is 1, 2, 3 and 4. That is your R chain, right? I can write it as R. Now students, the rule for assigning the absolute configuration or notation is that the group with the group having the lowest priority, the group having the least priority should be away from viewers' eyes, right? That is, it should be on the back side. Now in your wedge and dash formula, you must be knowing that your dash indicates what? That it is on the plane of the paper, and the wedge indicates that this is away, right? Now in the first carbon, your hydrogen is on the back side, right? You can visualize this by the ball and the stick model. So your hydrogen is on the back side. Now let's assign the priorities. This is Chan-Ingold rule. How we assign the priorities? The atom with the highest atomic number is given the highest priority. This is the 1. So you need to compare the first atoms of the groups bonded. So this is the 1. Then if the first atoms are the same, in this case this is C, and in our case also it is C, then you move to the second atom. Here it's oxygen, and in this case it is what? H. So this will be given the second priority, this is the third priority, and the fourth. Then what you have to do? You have to move your eyes from the highest to the lowest priority. So if I am moving, I'll go like this is 1, 2, 3, right? Now if we are going clockwise, it is rectus. So here our first carbon is R, right? And let's take up the second carbon. Now in this case students, which is the group? What all groups are there? If I take up this carbon as C, there is R. It is given like this, COOH, and there is a wedge, that is hydrogen, and this dash, there is hydroxyl. Now in this case, what is happening? What is there? That your hydrogen is on the plane of the paper and your hydroxyl is at the back side. Now what is the rule? That the group with the least priority should be on the back side. Now students, if you are getting such type of a question when your hydrogen is pointed on the plane of the paper, you just find out the notation like that and then just inverse it. So if in this case, if I find out which has got the highest priority, hydroxyl, so this is the first one, the second one, and the third one. Now from where I'll go, I'll move my eyes from the group with the highest priority to the lowest priority. So I'm going counter clockwise or anti-clockwise. So what am I getting? Sinister. But in this case, what is happening here? That your hydrogen is projected on the plane of the paper. So the actual configuration when this molecule is rotated would be R. Sorry, it would be R. So the answer here is R and R. Got my point? If the hydrogen is projected on the plane of the paper, what happens? That whatever the configuration you are getting gets reversed. Fine? So here you will be getting R. Otherwise, it will happen, say if you are rotating the molecule by 180 degree, you will get R only. So despite visualizing that, despite rotating that, look, you don't need to do that. You just find out which is on the plane of the paper, which is on the back side. Say if hydrogen is on the plane, is on the back side, no issues. Search for the priorities and move your eyes from the highest to the lowest priority according to your Chan-Ingold rule. But if your hydrogen is projected on the plane of the paper, it is not on the back side, just move your eyes from highest priority to the lowest priority, right? And whatever configuration you are getting, just inverse it or reverse it. So if you are getting R, the actual configuration would be S in this case, right? So students, it's actually very difficult to visualize a 3D molecule. So you can take up this. You just remember that when it's a dash, it is projecting above the paper. When it's a wedge, it is behind. And hydrogen should always be behind. If hydrogen is projected on the plane of the paper, find out the notation and just inverse it. Fine? Otherwise, you'll have to rotate the molecule by 180 degree, then visualize it, what all things will be there, and then set out the priority. That will take more time. Okay?